Okay, let's start. Hi guys, my name is János, working for Sequence IQ. We are a small startup from Hungary, Budapest, which means that I suffer from a terrible jet lag. Yeah, today I'm going to talk about Docker-based Hadoop provisioning. And we're going to talk about our motivations, the technology stack we use to provision Hadoop on Docker, the problems we faced during this provisioning, and the results and achievements we had. So basically, the goals and our motivations were quite simple. We needed to provision Hadoop on many environments, and we were doing this all the time over again. Initially, we scripted for all these environments. Then it was we had to maintain all this for different environments. So it started to be a pretty tedious task, and the DevOps guys were not really happy about this. So basically, we wanted to use Hadoop provisioning literally everywhere. Then we wanted to automate and unify the whole process, obviously scripted, being able to repeat the whole process and get the same results on different or the same environment all over again. To be able to start arbitrary cluster sizes using the same scripts or the same methods, basically. And as we move through the dev, QA, UAT, and production, we wanted to use the same lifecycle. So basically reuse the same cluster lifecycle and move these containers. Another nice feature which we needed, because most of our deployments are in the cloud, is auto-scaling. Initially, it was only scaling Hadoop, upscaling, but now up and down scaling Hadoop. And the last feature which we wanted to do is quality of service on Hadoop. So offer a quality of service solution for our premium customers. Our approach is quite simple. Then we are going to dig in details in a couple of minutes. But basically, the approach is to use Docker as much as possible to build the Dockerized cloud images, provision the cluster on the cloud, and then use Ambari to provision the Hadoop cluster. So this is the short story. Then let's kick in Docker. So how many of you guys have used or tried out Docker? Okay, cool. So basically, Docker, it's a container-based virtualization framework. It's extremely lightweight and it's portable. So basically, the same Docker container you can run on different environments, on every environment which does support Docker. And these days, more and more environments or OSs support them. I mean, we all know, as Java developers, the slogan that build once, run anywhere. In Docker case, this seems that it's working. So you can move the containers between different environments, and you got the same results. As I said, it's pretty much like a VM without the overhead of the VM, which I'm going to expand in the next slides. The containers, the good thing are that the containers are isolated. They don't interact, so everything stays inside the container. So for example, in case of Hadoop, you would be able to provision different versions of, say, Zookeeper on the same cluster if you need to, by isolating inside a Docker container. And the nicest thing is that it's basically can be automated and scripted. You got the whole Docker image. It's how you create the whole Docker image can be automated. It's pretty much like a Vagrant file for those who are familiar with Vagrant. So Docker containers. This is a comparison between a VM and a Docker container. As you see, you got a host OS in both cases. But in case of the Docker, you don't have the overhead of the OS because the Docker container shares the OS, and in a couple of cases can share even the libraries. Myself, I'm running on my laptop. So initially, we've been obviously developing on different sandboxes like Hortonworks, HDP sandbox, running on my laptop, and now I'm able to run a 4 or 5 node cluster on my MacBook with actually less overhead than I had with a VM, with a sandbox. And it's a it's a valid cluster. It's not a single node. It's not a single node VM, but it's a Hadoop cluster, a 4-node Hadoop cluster. Those who are interested and would like to see a demo, then we're going to have a meetup actually this afternoon from 3:30 about Docker and Ambari shell. And I'm going to do a demo over there, like how I'm spanning up a 4-node cluster or whatever node cluster on my laptop. The next key component in our stack is Apache Ambari. I don't want to enter into many details because there were lots of good talks about Ambari during the Hadoop Summit. The key points of Ambari, just to recap, is that the main goal of Ambari was to ease Hadoop provisioning, basically monitor and manage the whole cluster through a web UI or a REST-based API. And one of the key features, which actually it's a very nice feature of Ambari, is blueprints. It was introduced in 1.5.1, if I remember correctly, and now it's fully supported on 1.6. So blueprints are basically your cluster definition, which defines the component layout, your stack definition actually, and the component layout within your Hadoop cluster. That's a blueprint. Obviously, Ambari has a very nice REST API, and now a CLI shell and a Groovy client where you can interact with Ambari without using the web UI. That's the key things about Ambari. And yeah, if you are about to use Ambari to create a cluster, basically you need to do two things. First of all, you need to define the blueprint, which I said it's the component layout and the stack definition. And the second thing, you basically just need to post against this resource to create a cluster based on the blueprint. There is an intermediate step where basically you define your host within your host groups in the blueprint, which means you can, basically that's the point where you set up the hosts against the host group, and you don't know which service is going to run on which host. Obviously, the cloud environment, this is, if you want to do, say, one post, and you want to spin up a Hadoop cluster in a cloud environment, this is can be an issue, because first of all, you are not going to know the IP addresses beforehand if you want to use the IP addresses. Second, you don't know the DNS names either, or you don't know how many clusters or how many nodes, for example, you are going to have. So let's briefly talk about the issues we had provisioning Hadoop on Docker and different cloud environments, or actually even physical hardware. So if you are talking about the cloud, the first key point is like every cloud provider has his proprietary API. So if you are about to provision a Hadoop cluster on EC2 or Azure, then what you are going to do is basically you would have to create those calls. You have to code it yourself. Then you would have to create the images, the cloud images, which you are for each provider which you are about to use. The biggest problem, or one of the biggest problems, is the network configuration. Obviously, the good thing with EC2 and Azure is that they do have an API to configure the networks. Obviously, OpenStack, which we are about to support quite soon, has his own stuff on using Neutron. There are other ways how to do SDN on cloud providers. As I mentioned, for one of the key points for us was auto-scaling, and automatically nodes are coming and joining or leaving the cluster. So service discovery is one of the key points we had to solve in this case. And yeah, resizing the cluster, supporting failover dynamically, supporting member joins, basically all the things which are related to scaling or auto-scaling a Hadoop cluster. So what was our approach let's start with details. So first of all, you need to build your Docker image, which means you got a couple of options here. One of the options is that you install or pre-install the Hadoop services on a Docker image with Ambari. Then you have to install Serf and DNS masks on the Docker image. I'm going to expand we're going to enter in detail soon. Then the other thing is you would need to build the cloud image based on the Docker image, which you have just built. We automated everything, and we use Ansible for that. And at the end, you would need to provision the cluster. So building the Docker image. You would have, first thing you need to do when you are about to build a Docker image is you create a Docker file. As I said, it's pretty much, it's like a Vagrant file for those who are familiar with Vagrant. But it's just the output, it's a Docker image. Obviously, that Docker image, if you would like to distribute, what you are doing is you are not building the Docker image, but you have Docker IO to build the Docker image for you, because that's a trusted authority who builds Docker images or distributes Docker images. And as I said, optionally, you can pre-install the components with Ambari. And for example, if you pre-install the components, if you do pre-install your components with Ambari, and you push to Docker image, that has to go into a private repository, because with Ambari, there are some licensing questions around Nagios and Ganglia, so you might not be able to distribute. So this Docker image, actually, you cannot distribute. You can use our Ansible script and build your Docker image for yourself, but you can't distribute it over the internet because of the Ganglia and Nagios. For example, if your stack is HDP, that one you can distribute because it's running under an Apache 2 license. Next step you would need to do is you have to build your cloud image. The good thing these days are that more and more companies, cloud companies, are supporting Docker natively. So Amazon, for instance, is supporting the Amazon Linux distribution, does support Docker natively. OpenStack, since last year, does support Docker on the hypervisor natively. And basically, you can run Docker in your on-premise bare metal if you wish, because you can use boot to Docker, for instance. Next step is you can use Ansible to provision actually the image template. So as I said, we automate everything. So we don't build the cloud, neither the Docker images or the cloud images. We don't build manually. So we use Ansible in order to provision the image template. We pull the Docker image for Docker IO from the private repository. And you apply to within the cloud image, you apply your custom infrastructure configuration. There is one key thing about this is that since we wanted to provision Hadoop mostly in the cloud, but even on bare metal, we put everything which is possible inside the Docker image. So these Docker images can be shipped between different containers, different cloud providers, for instance. And the only thing which is outside the Docker image is the network, actually not even the network, but the infrastructure configuration, which is proprietary for every cloud provider. And then once you got this image, basically, in our case right now, we support EC2 and Azure cloud by using the Ansible playbooks. Few questions, because I mentioned Ansible a couple of times. So Ansible is basically, it's an IT automation tool. It's pretty much for those who are familiar with Chef or Puppet. It's pretty much like Chef or Puppet with quite few advantages, at least we think so. Is that the first thing is that it's configuration as data, which means that basically your configuration file the data actually describes your infrastructure. We think that it's the simplest way to automate IT because, first of all, it's not a server-based approach like Puppet or Chef. It's an agentless approach, and it's secure. The only thing you need to have on the hosts where you're about to do something is SSH, and most likely you do have that anyway. Ansible is goal-oriented. You've got a playbook, for example, and there are lots of predefined modules. There are modules for EC2, there are modules for Azure, there are modules for OpenStack. If there are no modules which you couldn't find, you can write your own module. And what does it mean is like you create your Ansible playbook, and you can run that playbook against different providers without any modifications. In most of the cases, those modules are already there. And we use Ansible to build those cloud images which I mentioned with a Docker container inside. Apart from this, we use Ansible for many things, like for all CI/CD process within a sequence IQ, but that's a different story. So provisioning. You have all these images built up, and obviously there are lots of problems. These are the main problems which we had to solve. So first of all, since we run inside Docker and everything for us is within a Docker container, the main problem is that the host file in a Docker container is read-only. So you're not going to be able to add DNS names. You're not going to be able to add anything, and that can be a problem when you're about to provision Hadoop with Ambari. The other problem is that everybody needs to know everybody, which means in a Hadoop cluster, all these nodes are running different services. They have to talk with each other. So you definitely need to know how many nodes you have, who are those nodes, what are the DNS names or the IP addresses of those nodes. Obviously, these things you could solve with a DNS server, setting up a DNS server, your private DNS server within the cloud, which can have some implications, like could be a single point of failure. Obviously, you can fix that and have a replicated DNS server, but that's just going to add some IT management overhead for you. And as I said, we are talking about a dynamic cluster where nodes are leaving and joining and failing. So potentially, you would like to have these things being automatically solved. So you don't want to reconfigure if you are about to set up a DNS server. You don't want to reconfigure your DNS server each and every time, because that can be a management overhead and can be an overhead on a DNS server actually. The other big problem is routing. So routing in general can be a problem in cloud. In this case, it's even a bigger problem because you have different containers running within the host. You can have one container where actually you can have, if you are running a pretty powerful cloud image, you can have multiple containers, Docker containers. So for example, on one cloud image, you can have three Hadoop nodes or whatever. So you need to have the ability to inter-host container routing, which means these Docker containers, they have to talk with each other inside the host and with Docker containers on the different hosts. And obviously, now as you issue IP addresses to these containers, you would like to have a collision-free IP address issuing for the Docker bridge. So how we solve this? So first of all, for the fully qualified domain name, it's quite simple with Docker. The only thing you need to do is just add a -h switch, which means the host name, which you come up with some random host name. You have to be sure that that host name is unique, because otherwise the cloud provider, you might route, if that host name does exist somewhere outside, you might route outside of your VPC, and you specify a DNS. I'm going to enter in detail soon what does it mean. For the DNS, how we solve these DNS problems, instead of having one or two DNS servers, main DNS servers, because each and every node is dynamic and every Docker container has to know about the rest of the containers, we use DNS masks, which is running inside the Docker container. And one of the key components of this whole networking issue solving is Serf. Since the members, you've got these member events in Serf, these events are trigger a DNS mask reconfiguration. So if a member fails, then basically Serf is going to regenerate your DNS entries on DNS masks. And for routing, that's quite simple. You just have to follow a convention for the Docker bridge. And for example, on EC2, you just use the reservation index, which is and within a reservation, you're going to have a launch index, and that you can use that, for example, as a convention to issuing out IP addresses for the Docker bridge. So Serf, I mentioned Serf. So Serf is basically, it's a decentralized cluster membership management solution. Pretty much, it's solving the same problems like ATCD, Zookeeper, or DoZerd. The only difference between Serf and these three is that Serf is first of all it's agent. It doesn't need a server, so you don't need a quorum of server to be operational. It's gossip based, so it's not Heartbeat based, which means it fits pretty good in WAN and LAN. There is no, I mean, actually you can do it in quite large networks. It's working quite well. You don't have the Heartbeat overhead. What it does for you, it does service discovery. So if you have Serf agents running in inside Docker containers or inside any nodes, this Serf is going to provide you membership management, like when a member failed or a member joined the cluster, these things are going to gossip to all the members in the nodes. This is one way how you know whether a Hadoop node has failed or a Hadoop node has joined the cluster, for example, if your load changes, without doing anything manually. So this is all automatically done. Again, Serf is decentralized, so all agents on Serf are basically, they are equal. It's pretty lightweight, the agent. It's highly available. It's DevOps friendly, which means that all the configuration for the Serf agent, like for example, the parameters on an event are environment variables. So for example, imagine you store some stuff in Zookeeper and something goes wrong. First of all, you would need to have most likely a Java developer or somebody who knows Zookeeper in order to pull those configurations out from Zookeeper and see what was your actual configuration. With Serf, these are all environment variables. So anybody who can log onto that box just gonna see what was the configuration. There are a couple of key components. So as I said, we use Serf to solve the network problems and the membership. There are a couple of projects which are pretty much solving the same things. So one of them is Consul. It's done by the same guy, Consul. So Serf is membership management for nodes. Consul is basically, it's going to be the focus is not on nodes, but the focus is on services. So what you are going to be able to do with Consul is basically you can track the health, for example, of your services running in a box. Again, for networking things, you can tackle this from different approach, like using, for example, Open vSwitch or Pipeworks. These are all things related to Docker containers. Pretty much is the same stuff like CoreOS. However, CoreOS is built on ATCD and Docker. So let's see how service discovery works in Serf. So as I said, first of all, it's gossip-based, which means that it goes through, you don't have the overhead of Heartbeat. The other key important thing is that you've got different profiles. You can set different profiles, like a LAN profile. You can set up, if you are within a network, you can set different parameters and the different profiles actually, and it does work between different data centers because it does support the WAN profile. Provides membership information. The key thing is it's got lots of event handlers. So the main event handlers is like the member join, member fail, member leaving, and you can have custom event handlers. You can write your own event handler when an event happens. And actually, you can query nodes one by one. So if, for example, say if I was talking about Ambari before, you've got different host groups and you've got hosts within those host groups, you could tag those hosts for the Serf agent, and you know that, for example, these are the hosts who are running, say, AH-based region servers. And you don't have to ask or query the whole cluster because you tag those agents, you can have as many tags as you wish, and you can query only those agents about the state, or actually you can subscribe to these events only for those who had this tag. So you can pretty much isolate services. So let's see how gossiping works in Serf. For example, if the agent 2 fails, then you're going to have the agent 1 one of the agents talks to agent 2 and it can't connect. What's going to happen, instead of waiting for a Heartbeat, what it's going to do is gonna pick up a random number of agents and gonna ask them, hey, do you see this guy? I can't talk with him. It might be a network problem between me being agent 1 and agent 2. Can you check whether you can talk with them or not? They're gonna probe the agent 2, and if they fail, then basically it's going to be gossiped throughout the cluster that agent 2 actually is gone. So you don't have to wait for heartbeat from agent 2. And this is one of the things we are using for regenerating the DNS mess, for example, on the Docker container. So when you see you got the join event, when a Serf agent receives a join event, what we do is basically we're gonna get either the IP address, or we broadcast either the IP address or the host name, and then the Serf agent is just quickly gonna regenerate the DNS mask entry. DNS mask is one of the components which I mentioned. It's a pretty lightweight DNS DHCP server. It comes with most of the Linux distributions. I think we don't have to spend too much time on this. So let's see an example how we provision Hadoop on EC2 within Docker containers. So first of all, what you would need to do is you use the REST API of EC2 to provision those instances which have the Docker container, pool actually the Docker container. You start one container, the first container actually, which is going to be, say, the Ambari server, and the rest of the containers are gonna run the Ambari agent. Now you have several options. You can either connect the Ambari UI, or you can connect the Ambari shell and start provisioning Hadoop on these nodes. Hold on. Yeah, you define the blueprint, and basically you provision the cluster. You start up the Docker containers within the EC2 images, and you're gonna have a fully working Hadoop cluster. It's obviously with EC2 and with any other cloud provider, we strongly suggest you to use to create your own private networks, to use VPC wherever it's possible. Don't start instances in default VPC. You would have to configure. So these are the things which are not inside the Docker container, because these are proprietary for EC2, for example. So the routing table, the security gateway, ACL, whatever you want to apply to your custom infrastructure is outside the Docker container. You apply these through the EC2 API. Good thing about EC2 is that they've got a thing called CloudFormation, which is a template-based stack definition, basically. It's almost like the blueprint for Hadoop. So the CloudFormation is like a blueprint for your infrastructure. You can manage your whole stack together. You can have this CloudFormation template or your stack definition actually put under version control, which means you can always recreate on EC2 the same stack, and you are sure, since there are no manual steps involved, you are pretty much sure that you have created the very same stack on QA, for example, on prod or dev. You can customize, obviously, at runtime. You can always add nodes at runtime. And basically, this thing saves you like 60 API calls, and it's all for free. So we strongly suggest, if you want to set up an infrastructure on EC2, probably the first thing you should check is CloudFormation. We went through all this process, how we do this Hadoop provisioning on different cloud environments using Docker. There were 4 main steps which you had to follow, and it's pretty error-prone. So obviously, you do realize that it sounds good, but if you are about to do these steps all manually, it's going to take you a while. So we came up with a project called Cloudbreak. Cloudbreak is a server breakage as well, whatever, it's got a good name. So basically, Cloudbreak is a cloud-agnostic Hadoop as a service API. What does it mean? Literally, in a simplistic way, it means that you've got a Hadoop cluster in EC2, Azure, and as I said, OpenStack and bare metal is coming with one click. So if you want to set up a 10-node or 100-node cluster, no difference. You choose your favorite cloud provider, one REST post, and you're going to have your cluster up and done. Obviously, you're going to have the options to configure we're going to provide you a different default CloudFormation stack. If you don't like, you can choose that. We're going to provide you a couple of blueprints, Ambari blueprints. If you don't like, you can always choose that. But in general, with one click, basically, we are going to be able to provision this cluster. And this project, we're going to open source it in approximately in 2 weeks. We don't want to build a service out of this. This was only a necessity for us because we needed Hadoop clusters in the cloud and different cloud environments, actually. And the ability to quickly provision Hadoop clusters, do some tests, ramp down, and basically increase or decrease the cluster with the load. So what are the benefits of Cloudbreak? One of the key benefits are, obviously, it's elastic, so you can set up as many nodes as you wish. It's scalable. If you want to add nodes, then it's gonna support that. The blueprints I mentioned, and it's flexible. It allows you to create your own, use your own favorite cloud provider. So this is a Hadoop as a service API. As I said, available on EC2 and Azure, OpenStack, bare metal is coming. It's going to be open source under Apache too. Actually, pretty much we had the same goals as the Apache Launchpad project. So why we did this, what's next? Why we had to create a Hadoop as a service API? Because there are so many Hadoop as a service providers already out there. When we started this whole startup, so basically for us, everything was about Yarn. We wanted to run everything inside the Yarn cluster. For example, Tomcat or any servlet container, Flume, all the components which actually right now are running in Yarn, but even components which are not on Yarn. Obviously, the Hoya project helped us a lot now, Slider. It has the same goals, so the guys from Hortonworks are solving these problems for us. We created a couple of custom providers, as I said, Tomcat and Flume. We had to make some changes on Flume, which we contributed back in order to get these things working, because our goal is to span up Hadoop services as a service. So we don't span up only Hadoop nodes, we span up actually Hadoop services on different nodes, long-lived or short-lived, and when you don't need those services, we're just going to shut it down because you can save on costs and you can save on cluster load. Pretty much, this is controlled by a heuristic scheduler which we are working. So basically, our end goal is to provide the quality of service on Hadoop, shrink up and down the cluster, span of different services, and the end goal is basically it's going to be a platform as a service API. So we are coming from a Cloud Foundry background. We use Cloud Foundry and Spring a lot. We developed against that. So our end goal is to come up with something like Cloud Foundry on Hadoop, on different cloud providers. You don't have to care about anything. You just span up your nodes, your services actually, and everything. All these components are moving components, are dynamic components. Obviously, there is another approach, this Yarn 1964, which is an association between Docker containers with Yarn containers. That's another cool thing. You can run, actually, you can run a Yarn container as a Docker container, and that's going to provide you full isolation, or, for example, running different services, different versions of services. So this is, as I said, platform as a service. So the project is the Banzai pipeline, we call it, which is a RESTful application development platform for big data. So we have abstracted the whole complexity of Hadoop, the whole complexity of HDFS or the services, you can name it. And our end goal is to allow people to create data pipelines and job pipelines on demand on his favorite cloud provider, and those actually auto-scaling this. Again, there are lots of projects who are doing pretty much building pipelines like cascading. The key differences between cascading and the pipeline is that we've got approximately 44 pipeline steps right now, which are pre-configured, like machine learning, lots of MapReduce stuff. These pipelines, you build your pipelines without doing any coding. It's just basically these are just REST-based configurations. You create your workflow as a pipeline, and you have the ability to run this pipeline either as a batch job, as a MapReduce job, or you can run it on Spark as streaming job. So again, everything is abstracted. For the end user, the only thing they are going to choose is like batch or streaming. They don't even know whether this is running on Hadoop or whether this is running on Spark, for instance. And again, yeah, this is all dynamic. It's all the services, like for example, where you post against a resource and you build a data pipeline, like you want to get your data from here into your cluster, which is the Hadoop cluster in our case, in HDFS, for instance. You don't need to, for example, start a Flume agent or whatever. The only thing you do is just configure the location from here to there. We're going to start dynamically with slider. We're going to start the Flume agents on the different nodes. We're going to move your data inside the Hadoop cluster. And if you wish, in this data pipeline, you can inject ETL processes. We use Kai and Morphline. You can dynamically, you can inject, again, as a REST API, described as a JSON object. You can describe your ETL process. Kiteline does support, I mean, it's like huge ETL capabilities. Again, you just describe this as a JSON. You can even write your custom Java ETL process and just inject into the data pipeline. Again, as I mentioned, machine learning for the job pipeline, we do support the usual suspects like clustering, classification, recommendation, all these things. The only thing you would need to do is just configure the algorithms. You don't even need to write 0 line of code. You just configure this. All these things are going to span up dynamically. Once your job is done, with slider or through yarn, we're just going to shut down those containers. And if the load decreases, and what's your rule, it's up to you. If the load decreases on your Hadoop cluster on the node, on EC2, for example, we're just going to shrink down your cluster to the size which is actually you have configured, the minimum size of the cluster, for instance. I guess I'm running out of time, so pretty much that's it. I mean, this, as I said, this is going to be open source in like 2 weeks, but if you want to have a quick look, just send me an email or subscribe to our webpage, to the beta program. And yeah, feel free to contribute. Just a quick note, we use like 6 languages, or 5 or 6 languages to put these projects together. Obviously Java, Scala we use for all the MapReduce and the Spark stuff. We use Go for, we had to learn actually Go for Docker and Serf. We use Groovy for everything which is REST related, and we use R for the heuristic scheduler. We are actually building a model with R to be able to classify your MapReduce job or Spark job in order to figure out how long this is going to take and to see whether the resources in the cluster are actually available. And if you say, like, I want to finish my job in like 10 hours, and we see that the resources are not enough, then dynamically this heuristic scheduler is going to span up different nodes. So again, you can check our GitHub page. This is all there. Most of them are already open source under an Apache 2 license. Yeah, Cloudbreak and the Banzai pipeline, we're going to take off the private flag in like 2 weeks. So yeah, feel free to contribute or send pull requests or bugs or whatever. Thank you very much for coming. Yeah, I think you should use a mic.
You said you're running the Docker on your PC, on your Mac here.
Yeah.
Do you have instructions on how to do that so we can reduplicate it ourselves?
Yes, I can show you now, or if you come to the Ambari meetup from 3:30, actually I'm going to do a demonstration of everything which I did, spinning up an HDP cluster on my laptop or EC2 or whatever. The key thing is you need to use boot to Docker. But if you go to our website, or you check our blog, actually we blogged a lot about Docker, so everything is described there. Actually, we provided even a script for you to span up. It's a one-liner. It's going to install you boot to Docker, chain to Docker for security, and then you've got a Mac or whatever you use, you're going to have you can span up as many Docker containers as you wish.
Okay. You're doing that?
You check our blog site. It's all there. It's like lots of information. If it's not, just send me an email. And,
okay. Thank you. You're doing it right now? Or you did it? Huh?
Or we can do it now or at 3:30.
3:30.
Whatever you prefer.
Okay. Ciao, thank you.
I don't. It's on the list. Where, do you know, Yusuf, where's the Ambari meetup? 211. Yeah, 3:30 and 211 if you're interested.
So I have a question about your auto-scaling. So can you explain more how that is related to Docker?
So the good thing with Docker is actually which didn't get through is like if I'm about to spin up a Docker container, it's going to take me milliseconds. If you spin up a VM, you know how long it's going to take. Now with auto-scaling, so you got this scheduler, which is a yarn scheduler, plus a couple of things which are related, are interconnected with the cloud API. So first of all, we try to figure out, we know there is a state in the cluster right now, right? So you know what are, for example, if you use the capacity scheduler, you know your jobs in the queue. Pretty much you can estimate based on historical data or based on the model which we are building in R, you can estimate how long it is for the queue to get empty. Now, you can do two things, either preempt the queue. Obviously, those guys who submitted the jobs in the queue are not going to be too happy, or you span up different nodes, and then you're going to have capacity, right? Pretty much that's it in a nutshell. We try to build a classification model when we based on the job profile and based on the data and the kind of the data, we try to figure out how long, and obviously considering the state of the cluster, how long it's going to take for this job to run. So this is like it's a research project, which actually is open sourced on our GitHub. So it's called yarn monitoring. So you can have a look there, and obviously we would be happy if you would like to contribute. This is something which is not going to be production ready in the next couple of months. It's a huge piece of work, but we are progressing with that.
But kind of a follow-up to that. So if you're, say, on AWS, then there's the cost of spinning up the AWS node.
Obviously,
or if you're
in the cloud, there is
on
always
physical, then there's the cost. Basically, you'd have to have additional capacity around.
You have to, with physical hardware, obviously this is not really going to work. So in physical hardware, the only thing you need to do is preempt your queue, right? Or people aren't going to be too happy. And that's the whole point with the cloud is like, yeah, you can shrink up and down, and you can save costs. It's up to you if you want to buy hardware upfront. The only thing with physical hardware, what you would be able to do either install OpenStack, and then you're not going to gain too much because you already had to pay for those machines, right? But at least those machines, you can take it off from your Hadoop cluster. And if somebody else wants to use those machines for something else, for instance, they can. But yeah, you do have the machines. It's just you can take them off or you can add them to your Hadoop cluster. It's a big debate whether you have to buy hardware or you want to use cloud. That's everybody's personal preference.
Are there any security problems with DNS mask?
It's running inside the Docker container, which is secure, so it's not. Every Docker container runs a DNS mask, which is just to know who are the rest of the Hadoop cluster members. But yeah, so we don't care about security because, as I said, we run everything in, if on Amazon, it's on VPC, so it's all secured, it's a black box. No one can actually get into your Docker box but you. Okay. Actually, right now, not even you, because there is no SSH on that. It's your option if you want to add or not.
Yeah.